Chemistry chapter 21 theory video 7. We are going to learn about equilibrium and solubility. Now solubility is the number of grams number of grams of any substance that would dissolve in a particular unit amount of water, like 100 grams of water or 1 kilogram of water. Now we know that most of the ionic compounds, they get dissolved in water, but there are some materials that would not get dissolved, so we classify them as insoluble salts. So now even though we say that they are insoluble, there is almost all of these ionic compounds get dissolved in water to some extent. Even to a very small extent, it will get dissolved. So now, for example, if you take sodium chloride, it is regarded as a soluble salt. In a saturated solution, it would have 36 grams uh, 36 grams of 36 grams of salt will be there in 100 grams of water. That means if you dissolve 37 grams of table salt in 100 milliliters of water, you will be left with 1 gram that would not dissolve. So it is going to be deposited as a solid at the bottom. So then what is a saturated solution? Saturated solution is a solution to which no more solute can be added, or no more you can add solute, but it is not going to get dissolved. So when we say a saturated solution, we are saying that no more solute can be dissolved in it. And then when you take lead 2 chloride, it is considered as an insoluble salt. However, a saturated solution would contain 0.99 grams of 0.99 grams of 0.99 grams of lead 2 chloride will get dissolved in it. That is something that we need to remember. Then we learn about solubility product. So when there is an equilibrium that is reached between when there is an ionic compound that is dissolved in water, and when it has reached the saturated point, what happens is there will be undissolved ionic compound in contact with the saturated solution. Then what happens is there will be a equilibrium that is going to be established between the undissolved solid and the saturated solution. What happens is at the same rate of the ions will move from the solid to the saturated solution at the same rate as they move from the solution to the solid. So that will happen. That means the positive ions and negative ions will move from the solid to the solution. Then at the same rate from the solution, it will get added to the solid. So this is what happens. They happen at the same rate. I hope that makes sense to you. So what happens is the equilibrium is going to be AgCl is going to be dissociated into Ag plus and Cl minus. Then Ag and Cl minus will join back again to produce AgCl in the solid. Right. Then in this particular situation, in the saturated solution, you will have an equilibrium AgCl solid, Ag plus Cl minus. So this equation, this is the equilibrium. So because that is the equilibrium equation, we can write an equilibrium expression for Kc for this. Kc equals Ag plus and aqueous concentration, Cl minus aqueous concentration upon silver chloride solid concentration. Because any solid, the concentration remains constant, we can write the equilibrium expression as Ksp. the concentration of the solid phase will remain constant, and that will be connected with Kc, and we are going to get something called Ksp, which is going to be the solubility product. Solubility product is going to be equal to Ag plus multiplied by Cl minus. So that is value. This value is quoted at 298 Kelvin. So what happens is we have Ksp is going to be, the general equation is going to be Cy plus aqueous to the power Ax minus aqueous to the power B. So we take this A to be the number of Cy plus cations in one formula unit of the compound, and B is the number of Ax minus 1 ions in the formula unit of the compound. We will understand it better when you look at the examples here. Fe2S3, Fe3 plus and S2 minus ions are what we have. So we have Fe2S3 solid and 2 Fe3 plus aqueous. So this is the equation we are talking about. Then you are going to get Ksp to be Fe3 plus to the concentration, that is let me write that again. You will get Ksp equals Fe, because it is Fe2S3, you will get the concentration of Fe3 plus, and all of these are in aqueous form, to the power 2, because it is 2 Fe3 plus. Then multiplied by S2 minus aqueous to the power 3. I hope that makes sense to you. So that is the Ksp equation. So if this solubility product only applies to ionic compounds that are slightly soluble, that is also something that you must understand. Then the solubility product, the units will have to be calculated based on what you have here. So here you are going to get the concentration squared and concentration cubed. Now if you take this one, in this particular example, magnesium hydroxide, then Mg2 plus OH minus, that is MgOH2, then it is going to be 3 concentrations multiplied together, mole cube Dm minus 9. So also remember, the solubility product applies only for sparingly soluble salts. So if the Ksp value is lower, this solubility product, the solubility, if this solubility product is lower, solubility of the salt is also lower. So if you can look at this, you will see that silver chloride, if you compare silver chloride and aluminum hydroxide is really not soluble. Then if you take ferrous sulfide, it will be 1 into 10 to the power minus 88. So that is going to be absolutely less soluble in comparison. I hope you understood. If you understood, please do question number 12. But before that, let's write a note. Write down the note, solubility product. Most ionic compounds dissolve in water. There are some ionic compounds which dissolve sparingly in water, and some are said to be insoluble in water. However, even insoluble ionic compounds dissolve in water up to at least a very small extent. Solubility is referred to as number of grams or number of moles of a compound needed to saturate a unit amount of water. Example, sodium chloride is a soluble salt. A saturated solution contains 36 grams per 100 grams of water. Then lead 2 chloride is an insoluble salt. A saturated solution contains 0.99 grams per 100 grams of water. Solubility product: when an ionic compound is in contact with a saturated solution of its ions, an equilibrium is developed where ions move from the solid to the solution and back from the solution to the solid at the same rate. For example, when silver chloride dissolves, following equilibrium is set up. Write this equation down. AgCl solid, equilibrium sign, Ag plus aqueous plus Cl minus aqueous. Then you will have, write down, this can be expressed by the equilibrium expression Kc equals Ag plus aqueous, that is within the concentration of silver ions, that is inside the square brackets, multiplied by concentration of Cl minus aqueous ions divided by AgCl solid concentration. Put a star and write down, for any solid, the concentration of the solid phase remains constant, and this combined with the value of Kc, we can write an equilibrium expression for solubility product Ksp. Then write down, Ksp is equal to Ag plus aqueous concentration, Cl minus aqueous concentration at 298 Kelvin. General formula is this: Ksp within square bracket Cy plus aqueous to the power A, Ax minus aqueous to the power B, Cy plus aqueous to the power A, Ax minus aqueous to the power B. Write down example, Fe2S3 solid, this equation, Fe2S3 solid, reversible sign, 2Fe3 plus aqueous plus 3S2 minus aqueous. So then the solubility product equation would be Ksp equals, within square brackets, Fe3 plus aqueous to the power 2, S2 minus aqueous to the power 3. Put a star and write down, Ksp applies to only sparingly soluble ionic compounds. Sparingly soluble ionic compounds. The units would be the multiplication of the concentrations and their powers. So you understand how it is done. Please do question number 12. Now, they would ask you to do, after you have done question number 12, let's study this. You will be asked to do different kind of calculations using solubility product. So you need to know how to calculate the solubility of a compound using the solubility product. So let's see these worked examples. Then we would be able to understand how it is done. Calculating solubility product from solubility. So now here what we are trying to do is we are trying to calculate the solubility product from solubility. A saturated solution of magnesium fluoride MgF2 has a solubility of 1.22 into 10 to the power minus 3 mole per cubic decimeter. Calculate the solubility product of magnesium fluoride. So what we do is we write down the equilibrium equation MgF2 solid, Mg2 plus aqueous, 2F minus aqueous. So then we find the concentration of each ions in here. When 1.22 into 10 to the power 3 moles dissolved from 1 gram of solution, Mg2 plus is going to be 1.22 because it is 1 mole would be produced. Magnesium fluoride dissociates into 1 mole of Mg2 plus. So then it would have the same concentration. However, if you go to F minus, there would be 2 moles produced. So as a result, its concentration is going to be double that. Then concentration of F minus is going to be 2 into 1.22 into 10 to the power minus 3. Then we write the equilibrium expression Ksp Mg2 plus F minus squared. Then we substitute the values. Concentration of Mg2 plus is 1.22 into 10 to the power minus 3. But the concentration of F minus is 2.44 into 10 to the power minus 3. That has to be squared. As a result, you get 7.26 into 10 to the power minus 9. So that is the solubility product of magnesium fluoride. Now to find the units, we have the concentration of magnesium into concentration squared of fluoride. So first one is moles per cubic decimeter multiplied by moles per cubic decimeter squared. So that is mole to the power 3 dm minus 9. I hope that you understand that. Now going to solubility from solubility product. You find the solubility from solubility product. They have given the solubility product, you find the solubility. So they will ask, calculate the solubility of copper 2 sulfide in mole per cubic decimeter. You have Ksp for copper sulfide 6.3 into 10 to the power minus 36 mole square dm minus 6. So we start off with the equilibrium equation CuS Cu2 plus S2 minus. So we know that the copper concentration is equal to sulfur concentration. So then it is going to be Ksp Cu2 plus squared. It is the same thing actually. So then we substitute the values. Then we will get the concentrations. Cu2 plus concentration squared is equal to the Ksp value. Then we get the Cu2 plus concentration is the square root of that. We will get 2.5 into 10 to the power minus 18 moles per cubic decimeter is the solubility of copper 2 sulfide. I hope that makes sense. If it did not, please ask me questions, and if you won't, you can write down these questions on your book, and then you will be able to understand it better. And please do question number 13. Do question number 13. We will discuss the rest in the next video.